Hello everyone, welcome to my YouTube channel. Yes, in this video we are going to discuss a super topic in BSc Maths, that is vector space. Here, the vector space concept is similar to group theory and subgroup theory. Group theory and subgroup theory. Before going to the topic of vector space, first we have to learn some basic concept. Now let us see the basic concept here. First of all, see the definition here. Vector. Here, what is a vector? So vector means a physical quantity which has a magnitude and direction. A physical quantity which has a magnitude and direction is called a vector. A physical quantity which has magnitude and direction is called a vector. Next one is scalar. Here, scalar means a physical quantity which has only magnitude only. A physical quantity which has magnitude, it has no direction. Vector means it has a physical quantity which has a magnitude and direction. Scalar means a physical quantity which has only magnitude, it has no direction, that is called scalar. This is the definition of the vector and this is the definition of the scalar here. Now we will see the another definition, addition of vectors. Addition of vectors. If the vectors are in two-dimensional, what do you take? A bar is equal to, I am considering two vectors A1 comma B1 are the two. A bar equal to A1 B1 and B bar is equal to, I am taking A2 B2. These are the two vectors in two-dimensional. Here, if the addition of the vectors is A bar plus B bar is equal to what, right? A bar plus B bar is equal to what you get? A1 plus A2 comma B1 plus B2. Now let us see the example. A bar is equals to 1 comma 3 is one of the vector and B bar is equal to another vector 3 comma 1. Then A bar plus B bar become, what is the value? 1 plus 3 4, 1 plus 3 4. Now see this one graphically. Here for example, this is a value 1 2 3 4. Here 1 2 3 4. So what is the first vector? A bar. A bar is equal to, what is the value? 1 comma 3. Here x value is 1, y value is 3, this one. So it is a bar vector, vector A. Next B bar value is 3 comma 1. X value is 3, y value is 1. This is a vector. Here, this is a vector 3. Here the value is 1 comma 3 and this one is 3 comma 1. If we add two vectors, what is the result value? A bar plus B bar is equal to, what do we get? 4 comma 4 means 4. Here 4. This is the value 4 comma 4. It is the addition of the vectors. It is A bar, it is B bar and this one is A bar plus B bar. A bar plus B bar. It is the addition of the vectors. So A bar is a vector in two-dimensional, B bar is a vector in two-dimensional. If you add two vectors, what do we get? A bar plus B bar is equals to A1 plus A2 comma B1 plus B2. If the vectors in three-dimensional time తీసుకుంటారంటే A1 B1 C1, another vector is A2 B2 C2. What do you write? A1 plus A2 comma B1 plus B2 comma C1 plus C2. A1 plus A2 comma B1 plus B2 comma C1 plus C2. This is the addition of the vector. Now next we see the scalar multiplication. Next see the scalar multiplication. Scalar multiplication. Here scalar multiplication means, here we have to consider one of the vector. I am taking A bar is a vector. A bar is equals to, what we write? A1 comma B1. It is a two-dimensional vector. Here k is the any scalar. K is any scalar which is belongs to our real numbers, scalar value. The scalar multiplication means multiply a vector with scalar. What do we get? K A1 B1. We write this one like K A1 comma K B1. For example, 2 is a scalar and vector A bar is equal to, what do we take? 1 comma 2. Vector A bar is equals to 1 comma 2. Scalar multiplication, what it is? 2 A bar is equals to 2 into 1 comma 2. 2 into 1 comma 2 and 2 ones are 2, 2 twos are 4. It is a scalar multiplication value. The value is 2 comma 4. If you say this value is graphically ఏమొస్తుందంటే చూద్దాం. Here x values are 1 2 3 and 4. Y values 1 2 3, 4. So what is the first vector here? Observe. What is the given vector? 1, 2. Given vector is 1, 2. Here the point is x value is 1, y value is 2. This is the value 1, 2. If you multiply with 2, it becomes 2, 4. It becomes a 2, 4. What is the value? X value is 2, y value is 4. Here we get 2, 4. This the value is 2, 4. This is from here to here vector a bar. If you multiply with a scalar, it becomes like this. This is a scalar multiplication 2 into a bar. 2 into a bar. First, this is scalar multiplication. Scalar multiplication means we are multiplying a scalar with a vector. Now, next we will see the definition of the space and definition of the vector space and internal composition and external composition. Now, let's see. Here space means a continuous area. Vector space means in a space we observe the behavior of the vectors. We observe the behavior of the vectors under some conditions. Vector space in general, what is the definition of the vector space? Space means continuous area. In that area, if you observe the behavior of the vectors, if you observe the behavior of the vectors in a space, that is called vector space. It is general, but we have to say mathematically. So before learning the definition of the vector space, now see here. See the definition of internal composition. See the definition of internal composition. Here, definition of the internal composition is, internal composition, for example, VBA set. VBA set of vectors. VBA set of vectors means internal composition. Study only about V. You have to study only about vector set. If you study only about vector set, then that is called internal composition in generally. But mathematically, for example, capital VBA set of vectors. Capital VBA set of vectors. Here I am taking plus is a binary operation. Plus is a binary operation. For example, this is a complete set of vectors. The complete set of vectors. This set of vectors. If A comma B are the two vectors which are belongs to V. If I apply the binary operation between these two, A plus B. So addition of vector is again a vector. So A plus B is also belongs to V. Means here A comma B belongs to V. If I apply the binary operation, A plus B is also belongs to V. Since addition of vector is again a vector, so it is belongs to vector set. It is called internal composition. Internal composition అంటే two elements మధ్యలో then binary operation అప్లై చేసినప్పుడు వచ్చే రిజల్ట్ ఎలిమెంట్ కూడా మనం తీసుకున్న సెట్ లోనే ఉంటాయి. ఇంటర్నల్ ఆ సెట్ లోనే ఒక సెట్ లో ఉన్న ఎలిమెంట్స్ మధ్యలో ఆపరేషన్ అప్లై చేసినప్పుడు వచ్చే రిజల్టెంట్ ఎలిమెంట్ కూడా అదే సెట్ లో ఉంటాయి. ఇట్ ఈస్ కాల్డ్ ఇంటర్నల్ కాంపోజిషన్. అంటే ఈ సెట్ గురించి మాత్రమే డిస్కస్ చేస్తున్నాం. ఈ సెట్ కి ఎక్స్టర్నల్ గా ఏ వాల్యూస్ ఉన్నా, ఈ సెట్ కి ఎక్స్టర్నల్ గా ఏ వాల్యూస్ ఉన్నా మనకు అవసరం లేదు. వీఆర్ డిస్కసింగ్ ఓన్లీ అబౌట్ దిస్ అడిషన్, మల్టిప్లికేషన్, సబ్స్ట్రాక్షన్ ఆఫ్ this set only. We are discussing about only one set. It is called internal composition. Next one is external composition. Now we will see the definition of the external composition. Here let us consider two sets. It is a set V. It is set V and it is a set of scalars. It is a set of scalars. It is a set of vectors. Here A, B are the vectors in the set V. Here alpha is a scalar. Alpha or beta, any values, alpha, beta are the scalars in F. External composition means here A is the vector in V, here A is belongs to V, A is belongs to V and alpha is belongs to F. A is belongs to V, alpha belongs to F. If you apply the binary operation between these two elements, if you apply the binary operation between these two elements, A into alpha, here observe, A is the vector, alpha is a scalar, vector into scalar. Vector into scalar, again what we get? Vector. So it is belongs to V. A alpha belongs to V. It is called external composition. అంటే వెక్టార్ సెట్ లో ఉన్న ఎలిమెంట్స్ కి ఎక్స్టర్నల్ గా ఒక స్కేలార్ తో మల్టిప్లై చేస్తున్నాం. అంటే ద ఎలిమెంట్ ఆల్ఫా, దిస్ ఎలిమెంట్ ఆల్ఫా డస్ నాట్ బిలాంగ్స్ టు F. ఇట్ ఈస్ ద ఎక్స్టర్నల్ ఆఫ్, ఇట్ ఈస్ ద ఎక్స్టర్నల్ ఆఫ్ V. ఇట్ ఈస్ ద ఎక్స్టర్నల్ ఆఫ్ V. ఇక్కడ ఎక్స్టర్నల్ కాంపోజిషన్ అంటే వీలో ఉన్న ఎలిమెంట్స్ కి ఎక్స్టర్నల్ గా ఉన్న రిలేషన్స్ మధ్యలో ఏదైనా ఆపరేషన్ అప్లై చేసినప్పుడు వచ్చే రిజల్టెంట్ ఎలిమెంట్ కూడా మనకి దేంట్లో ఉండాలి? వీలో ఉంటే. ఇట్ ఈస్ కాల్డ్ external composition. It is a external composition. V is a set of vectors, alpha is a set of scalars. If you apply the binary operation between these two elements, what we get? Vector. Again what we get? Vector. It is a external composition. Internal composition అంటే ఒకే సెట్ లో ఉన్న ఎలిమెంట్స్ కి ఇంటర్నల్ కాంపోజిషన్ ఉంటే ఒకే సెట్ లో ఉన్న ఎలిమెంట్స్ మధ్యలో మనం రిలేషన్ అనేది చూద్దాం. ఇక్కడ చూద్దాం. ఫర్ ఎగ్జాంపుల్ హియర్ ఇంటర్నల్ కాంపోజిషన్ అంటే ఏం చెప్తాను, సెట్ వి, ఈ సెట్ లో ఉన్న ఎలిమెంట్స్ కి అడిషన్, సబ్స్ట్రాక్షన్, మల్టిప్లికేషన్ అన్ని చేస్తున్నాం విలో. ఓకే, ఇంటర్నల్ ఈ సెట్ కి మాత్రం, అవుట్ సైడ్ ఆఫ్ ది వాల్యూస్ కి మనకి ఎలాంటి సంబంధం లేదు. కానీ ఎక్స్టర్నల్ కాంపోజిషన్ అంటే ఏం చేస్తున్నారంటే విలో ఉన్న సెట్ లో ఉన్న ఎలిమెంట్స్ కి అవుట్ సైడ్ ఆఫ్ ది సెట్ వి అవుట్ సైడ్ ఉన్న ఎలిమెంట్స్ కి మధ్యలో మనము ఒక ఆపరేషన్ అనేది అప్లై చేస్తున్నాం. ఇట్ ఈస్ స్కేలార్ మల్టీ, జస్ట్ లైక్ స్కేలార్ multiplication. It is called external composition. Now we will see the definition of the vector space. Now we will see the definition of the vector space. What is the definition of the vector space? Capital V be a non-empty set. Capital B a any non-empty set, and V be a set of vectors. V be a set of vectors, and F be any non-empty set. F be any non-empty set, and F is a set of scalars. F is a set of scalars, and here f comma plus comma dot, and f comma plus comma dot is a field, and f comma plus comma dot is a field. Observe here, V is a non-empty set, it is a set of vectors. F is a non-empty set whose elements are scalar. V is a non-empty set whose elements are vectors. F is a non-empty set whose elements are scalar, and f comma plus comma dot, and f comma plus comma dot here, what is it? It is a field. మనకి సెకండ్ ఇయర్ లో వస్తుంది గ్రూప్ థియరీలో. f comma plus comma dot is a field, then the set v over f comma plus comma dot, then the set v over f plus comma dot is said to be, then the set v over f comma plus comma dot is said to be a vector space. It is said to be a vector space. V over f, it is called v over f plus comma dot is said to be a vector space over the field f if it satisfies the following condition. If it satisfies the following condition. Now see the conditions here. Now see this, these are the conditions for vector space. What is the first one? There is defined internal composition in V. There is defined internal composition V is called addition of vectors generated by place, for which V comma place is an abelian group. ఇదంతా చూస్తే సినిమా లాగా కనిపిస్తుంది, బట్ సింపుల్ హియర్. ఇక్కడ ఏం ప్రూవ్ చేయాలి? ఫస్ట్ కండిషన్ ఫర్ ది వెక్టర్ స్పేస్ ఇస్ V comma place is an abelian group. V comma place is an abelian group means V is a set of vectors. V is a set of vectors. The set of vectors satisfies closure, associative, identity, inverse and commutative property. The set of vectors V satisfies closure, associative, identity, inverse and commutative properties with respect to the place. ఇక్కడ ఫస్ట్ ఏం అవ్వాలి? V comma place is an abelian group. And second one వచ్చేసి ఈ కండిషన్ సాటిస్ఫై అవ్వాలి. This is the condition. ఇక్కడ A is the scalar, alpha is a vector, means scalar multiplication exists here. Second one is scalar multiplication. A alpha belongs to V. A is a scalar, alpha is a vector, A is a scalar, alpha is a vector, then the product is belongs to V. Then the product is belongs to V. These two are the condition. And third one, by using these two conditions, we have some properties here. ఏంటది? A into alpha plus beta is equal to A alpha plus A beta, A plus B alpha is equal to A alpha plus B alpha, AB alpha is equal to A into B alpha, 1 into alpha is equal to alpha. Here, 1 is the unity element in F. These are the conditions for vector space. First one ఏమాలి? Internal composition, external composition. In internal composition, V comma place is an abelian group. V comma place is an abelian group. Second one is there is an external composition in V over the field F. There is an external composition in V over the field F, that is A alpha belongs to V when it is possible. If alpha belongs to V, A belongs to F. Alpha is a vector, A is a scalar, then the external composition means scalar multiplication is belongs to V. By using these two conditions, we have another one condition. Which one? These are the four conditions. A into alpha plus beta, A alpha plus A beta, A plus B alpha is equal to A alpha plus B alpha, AB alpha is equal to A into B alpha, 1 into alpha is equal to alpha. Here 1 is the unity element in F. Here what is it? F is a field. F is a field. సో ఈ కండిషన్స్ అన్ని సాటిస్ఫై అవుతే మనం ఏమైనా రాస్తుంటే V over F comma plus comma dot, V over F comma plus comma dot is a vector space. V over F comma plus comma dot is a vector space over the field F. Over the field F. Okay, this is the important definition. Now